Assalamu alaikum everyone. My name is Marjani Badi. Today I will talk about the presenting my design for an automated metro station gate. Here is the metro station gate control system. The system uses sensor and digital logic manage passenger and ensure the safety. For the question one, we design a block state diagram, a system block diagram. For here, I designed the overall system architecture. For we use RFID sensor. From the RFID sensor, it has a yellow line to send an analog signals and analog to digital converter signals into a digital number representing how many people are crossing at once. A synchronous counter keeps a running a total of people on the platform, counting up when and someone enters and down when someone leaves. The main brain is finite state machine. It controls the gate opening the close it based on the passenger count and a signal from the ticket counter. If more than three people cross at once, an alarm logic circuit triggers and 555 timer, which activates a buzzer or light. Finally, a digital to analog converter sends the passenger count display in the control room. Here is all about it. Then I explain the explanation of this diagram. Uh, Now we talk about the answer to the question number two. Here we use the final state machine. Here is full state ideal check open close. Ideal the gate is locked waiting for activity. Check triggered when someone approach. If checks if the platform is full. For open, if the platform is full, the opens gate it keeps it when the until daily ticket limit is reached. Close once the ticket limit is hit, it closes the gate and returns to the ideal. I also provided here the Verli code for defines the which states and condition to the transition between them. Okay, let's start about another question's answer for question three. In question three, if the question three is about alarm circuit, the alarm must sound if more than three people cross simultaneously, since the system uses 4-bit counter or 4-bit counter. S3, S2, and S1 is not counted. That means the alarm activates any value from 4 to 15. Then the circuit we can use here in NAND gates only. The alarm output is connected to the reset at pin of the 555 timer. A high signal from the enables the timer and turns the buzzer. Turns the buzzer. A low signal disable the turning the buzzer off. Now let's about to talk to the answer to the question number four. Answer to the question number four is all about the 555 timer calculation. Here I calculate the component values for the 555 timer circuit used for the alarm. Based on my student ID, I calculate the required frequency and then 74% duty cycle. This gave me the high and low times of the timer outputs using the standard 555 formulas. I calculate the R1, R2, R2 and the C1 capacitor C1 and I needed the achieve timing. I choose a 50 farad capacitor because it resulted in more practical resistors value preventing the wasted power. I also draw a block diagram of 555 timer circuit. Okay, let's start to the answer to the question number 5. From 5, a digital to analog converter translate the digital passenger count into an analog voltage for the control room display. Control room display. Here we use 5-volt reference and a 4-bit digital analog controller. The voltage change for each passenger is about 0.33 volt, and for 5 passenger it average 1.6 volt, and for 10 passenger it approximately 3.33 volt. Okay, it's all about this, and then we talk about the answer to the question number 6. Answer to the question number 6 of all about the system limitations. Finally, I analyze the limitation of our purpose systems. Sensor accuracy. Sensor accuracy is all about the RFID readers can misread cards or fail to detect them. Simulated detections the system might be struggle if many people cross the exact same time. Exit management and the design only counts the people entering. It needs the separate sensor to count. No manual override. There is no way for security to manual control the gates in an emergency. Single point failure, or if the main controller fails, the whole system stops. It needs a backup. And scalability, changing the passenger limit requires hardware changes, not just a simple software update. Lastly, I talk about the design provides a solid foundation model for an automated gate control system using core digital logic principle. Assalamu alaikum, sir. এবার হইছে?